All right, guys, this is going to be the lecture for homework 15. This will be the only non-graphing homework on the third test, so be aware that everything here on out is going to be graphing related. Homework 15 is not. Homework 15 is going to be the topic of polynomials, and we're going to talk about how to add, multiply, and subtract, or add, subtract, and multiply them. No division here. And the word polynomial is kind of a little over the top, to be honest with you. You'll recognize this once we get into the material here, so no worries there. First things first, let's just go over some vocab. Some of this you'll know, some of it you won't. Variable, we've already talked about that. That's, you know, your X's, your Y's, your A's. It could be even these Greek letters, you know, it could be anything like that. The constant is going to be, you know, the number, -2, 1/4, something like that, okay? So we've talked about the basic idea that there's variables and there's constants. Now, what we haven't talked about so much is what happens when you combine them, and that's sort of what we're getting into today, okay? You'll have terms. So let's say we combine these, we had something like 2x to the third. Oh, that's writing much better. 2x to the third plus 7x minus 4, right? Okay, each one of these pieces is called a term. And we'll get into the combining like terms in a minute. I'm sure that's what your mind goes to when you hear that word. Each one of these pieces is a term, okay? So when we talk about terms, we're talking about separate pieces in an expression and an equation. Remember those? We can go ahead and cover that real quick. We already talked about this as well, but expression means there is no equal sign. An equation would be something that has an equal sign. We'll get more into that at a different time. So right here, this piece has 3 terms. We would call this a trinomial. Okay, so that would be the name of this thing. If it is, let's see here, if it is 1 term, we would call that a monomial, right? If it was 2 terms, we'd call it a binomial. We just saw that if it's 3 terms, we'll call it a trinomial. And if it's any more than 3, meaning 4 or more, we would call that a polynomial, okay? Polynomial. So it's just a matter of counting the pieces in the item. Whether it's 1 piece, it's a monomial. 2 pieces, it's a binomial. If it's 3 pieces, it's a trinomial. If it's anything more than 3, we just kind of generically call it a polynomial. Realize that truly all of these are polynomials, so it's sort of confusing. Every nomial is a polynomial, but strictly speaking, we only call the ones 4 or more to be polynomials. So just some, you know, vocab there you might want to remember. It works the same way with religion. If you believe in one God, you are monotheistic, like a Catholic or something. If you believe in multiple gods, 3, 4 or more, you would be polytheistic. Poly means many, mono means 1, bi means 2, tri means 3, all that kind of stuff, okay? So nothing crazy there. What else do we need to talk about? Let's talk about the word coefficient, and we'll put this all together in just a minute. I'm just kind of listing the stuff out right now. Coefficients. So coefficients, let's take that first thing we had there, the 2x to the third plus 7x minus 4. Let's take this expression, right, because there is no equal sign. The coefficients are the 2 and the 7, and technically the -4. The coefficients are the numbers in front of the variables, right? So this 2 is a coefficient, the 7 is a coefficient, and because the 4 has no variable, the -4, excuse me. A lot of people like to drop this one off. I'm not going to write it here, but couldn't I put x to the 0? We'll write it. Couldn't we put x to the 0 here? Doesn't that mean just there aren't any x's? But you could also put y to the 0, z to the 0. We don't want to sit here listing out all the things you don't have. So rather than sitting here saying it's -4 with 0 x's and 0 y's and 0 z's, we just say it's -4. But because there are technically variables attached, they're just 0 powers, it is a coefficient. Be careful. Also, this last piece, like we said, is a constant because it also has no variables attached to it. So just several different words we want to talk about. Okay, let's kind of put this in action, see what you might get asked on an exam or something. So let's say I gave you something very similar to what we just had. Let's say 7x squared minus 10x plus 3. Okay, unless I asked you several questions about this. I asked you for the name. All right. I asked you for the terms, the constant, the coefficients, and there's one more which we'll talk about at the end here, which is the degree. So just some vocab you need to know here for these things. First of all, the name, just like last time, there are three pieces, 7x squared minus 10x plus 3. So the name would be a trinomial. All right. The terms, we just mean what are the terms? Well, 7x squared is one of your terms, right? That was the first term. Just count them. You said there was three of them, so what are they? The first one is 7x squared. The next one is negative 10x. And the last one is 3. Those are your three terms, right? You just told me there's three of them, trinomial, so here's the three terms. The constant is the piece with no variable on it, so that'll be the 3. The coefficients, and again, it is plural here because there are multiple, right? The first one is a 7, is the number in front of the variable. The next one is a negative 10, the number in front of the variable. And the next one is a 3, remember, because the constant is considered a coefficient. Last is the degree. The degree is simply the highest power. You have power 1 here, you have power 0 here, and you have power 2 here. We like to write them in highest power order first, so write second, x squared rather than x to the first and then no x's. So the degree here would be 2, the highest power, okay? Simply a vocabulary situation, nothing crazy. Let's do another, let's do a couple more actually. Let's do negative x to the 5th plus 17x to the 3rd minus 4x plus 4, something like that, right? So let's go through and we'll do the same, 5 questions. What would the name of this thing be? Well, this one has 1, 2, 3, 4 pieces. Remember, we said if it has 4 pieces or more, it's just a polynomial. We don't start saying quadnomial and stuff like that. It's just a polynomial. The terms, if you were asked to list them out, are the 4 things you counted. Negative x to the 5th is the first term. I'm not putting pluses and minus between them because that would just be rewriting the polynomial. I'm listing them, right? 17x to the 3rd, negative 4x, and 4. Those are your 4 pieces to make your polynomial. All right. The constant is the piece with no variable on it, which in this case would be 4. The coefficients in order, right? Because that is the thing, you want to have them in order. Highest power first. The coefficients, what's the number in front of this first piece? It's negative 1, yeah? If it was just x to the 5th, it'd be positive 1, right? So the coefficients here are negative 1, number in front of the variable, remember, 17, negative 4, and remember the constant is considered a coefficient, so positive 4 as well. And the degree is the highest power. And if you write it in the right order, the highest power should be the first one, so the degree is 5 because that is power 5, all right? Does that make sense? We'll do, let's do one more real quick. We'll kind of squeeze it down here in the bottom, block this off. And this is honestly the one that will cause the most problems. People get these, no problem. Then I give them something like this and it really throws them off. Let's say I gave you 8a squared b to the 3rd. That's it, 8a squared b to the 3rd. What would the name be? Well, this one only has one piece, right? So this would be a monomial. Okay. The terms, well, there's only one term. Remember, the terms are separated by pluses and minuses. If it's all multiplied together, that's one term. The constant is the piece with no variable on it. Which piece has no variable on it here? Well, nothing, right? So 0. Because you could put a plus 0 on the end, I suppose. The coefficient, in this case, there is only one, is the number in front of the variables. In this case, it is 8. And this is the tricky part. Let me make sure it's on camera here. The degree. The degree is the highest power, but this is all one term. So you actually have to add the powers up. Up here, this only had one power, so its degree was 5. Here, it has a squared and b to the 3rd, so this piece has a degree of 5. If you're talking about one piece, you have to add up the powers. Up here, I didn't do that because this was just one piece. I didn't say 5 plus 3 because this was just one piece. This is just one piece. So the degree is the highest power when you combine them. So 2 and 3 makes 5. This piece has a degree of 5, and that is the degree. So be a little bit careful. If there's multiple variables on one piece, you do have to add the powers to get the degree, all right? So that's really the idea, the vocabulary you need to know. We're going to say the words coefficient, terms, and all that stuff. So make sure you're comfortable with that. The idea in this homework is to combine polynomials. They'll add, subtract, multiply them. So let's go ahead and get into that. First, let's talk about this idea of like terms, because I'm going to say that a couple times from now on. I'm going to say, let's combine the like terms. Let's make sure we understand what like terms are. If I asked you to take x plus y and put those together, what could you do with it? Nothing, right? X plus y don't go together because they're not like terms. So couldn't we agree, certainly, they have to have the exact, and I do mean exact same variables. In this case, just x and y aren't the same variable. What about if I said something like 2x squared plus 3x? Can I combine those? Well, the answer is, again, no. I mean, they're not, nothing happens. It just sits to what it is, because not only do you have to have the exact same variables, you have to have the exact same powers or exponents, okay? So x and y don't go together because they're not the same variables. X squared and x don't go together because they're not the same powers, right? What if I had something like negative 9x plus 7y plus 2x? And the instruction here would be simplify, which just means combine it down as much as possible. Here we do have like terms, right? You're going to want to pay attention because most of the homework's instruction is going to be simplify. Simplify in this case generally means combine like terms. So we have negative 9x. We have 7y, which will not combine with the x, and we have 2x. You can put your x's together, right? They have the same variable and they have the same power. So negative 9x plus 2x, that's negative 7x. And then we still have the 7y we didn't do anything with, and that's it. You're just combining like terms. There's nothing crazy, but we probably want to have a definition for exactly what like terms means, okay? So let's go ahead and step this up, try a little more difficult one. And again, don't worry about the names, right? The homework might say something, you know, like this. It might say, add the trinomials, and it'll give you something like this. And remember, the instruction here would be simplify. I'm not going to keep writing it, all right? So let's say the homework kind of gives you something like this, a lot uglier looking than what I just gave you. And it says, I want you to combine these trinomials. Does it really matter if they're trinomials or if they're binomials or anything like that? And the answer is no. Simplify here means two things. It means to distribute if possible. We'll talk about that in just a second. You already probably know what that means. And once you've distributed, if you can, you're going to combine like terms, if possible. Both of these steps are not necessarily going to happen. You're going to distribute if possible, and you're going to combine like terms if possible. So let's come down to what we had here. Distribution means, is there anything to multiply in front of the parentheses? So in this case, no. Is there anything to multiply in front of this parenthesis? No. Is there anything to multiply in front of this parenthesis? You could say positive 1, but that doesn't really matter, right? Then so we can't distribute. Can we combine like terms? Well, the parentheses sort of throw it off, right? Can you do anything inside the parentheses? Because order of operations is still in effect here. Does 3x squared and 2x and 10, can they combine? No. Can 4x squared and 6x and 9 combine? No. So what's the point of the parentheses? Simply to say that it's a trinomial plus another trinomial. That doesn't matter. You'll see in a minute. We'll do a trinomial binomial. It just doesn't matter. So distribute if possible. We already said there's nothing to multiply by, so there's nothing to distribute. So now we just combine like terms. And if you want to, once you realize there's nothing to do inside the parentheses and there's nothing to multiply to the parentheses don't really need to be there. So if you'd rather just get rid of them, you are able to do that. Remember, we like to do the highest power first. So 3x squared and 4x squared is going to give us 7x squared. Because you're just adding, the powers will not change. You have 3x squared, you have 4x squared. You're going to have 7x squared. Remember, when did the powers change? When we multiplied them, right? Like the product rule. Now here we've got 2x and negative 6x. 2x minus 6x, that's negative 4x. And then here we got negative 10 and negative 9, and that's negative 19. So you took this trinomial, you added to this trinomial, and this is what you got. You simplified it, right? You didn't solve it. You couldn't go much further with it. You just simplified it. That's it. All right. What if we said, take this binomial. Let's squeeze this in down here. Trying to use less paper. Let's say we took this binomial and I told you to add it to this monomial, right? So this is our first problem. This is our second problem, just to keep this all clear. And this is our third one. So again, the instruction being simplified, distribute if possible, combine like terms. Now here we can distribute, right? Distribute means, can you multiply something to the parentheses? Off to the side real quick. Distribution officially looks like this. If you're not comfortable, if you've not seen this before, you have to have a high school diploma to come to Santa Fe. You've learned this before. Distribution. It would mean if you got two things inside that can't be added, you multiply to both and it'd be A times B plus A times C. And it could work with a minus as well. Some of y'all don't like those official definitions, but that's what distribution means. It just means if you have something sitting right outside the parentheses, it multiplies to everything inside the parenthesis. So in this case over here, we have 2 times 3x, which gives us 6x. 2 times -9, which gives us -18. The 2 does not go to the 5x because the 5x is not in the parentheses, right? Distribution means to clear parentheses with multiplication. So we were able to do that here, but this 5x just sits alone. And then we combine like terms. 6x and 5x, that makes 11x. The -18 is just sitting there by itself, and that's the answer. Again, think about the fact, did I use the fact that this is a binomial and that's a monomial at all? No. The names for these things don't matter other than if they ask you for them. I mean, yes, we did a trinomial plus a trinomial and a bunch of monomials and a binomial and a monomial. But if you start thinking like that, it's just going to confuse you. I would strongly suggest you stay away from that, the labels, unless you need them, unless the homework is asking you, is this a binomial? Is it a trinomial? Labeling them doesn't really help. It's simply a definition thing, okay? So let's keep going. That's really the idea here. And what we're doing now is the adding and subtracting, right? We're adding and subtracting polynomials. We just added a trinomial, then we subtracted a monomial and a binomial. Again, the names just aren't a big deal. Let's say I gave you something like this. And again, remember, the instructions on all of these are just going to be simplify. It'll be nice, you know, the computer might be sweet and tell you, oh, simplify by distributing, but in general, it's just gonna say simplify, which again, means distribute if possible. These are if possible. It is not a guarantee it will happen. And then the second one is combine like terms, if possible. I mean, presumably something will happen, but there's no guarantee anything really. So distribute first. We have 2 times the 4x and the 2 times the -8. So 2 times 4x is 8x. 2 times -8 is -16. And remember, it only goes to the things in the parentheses it's right next to. Now over here, is there anything to distribute? Yes, a negative. If you distribute a positive, think about the one we did a minute ago. I said there's nothing to distribute, right? I said we have this trinomial here. There's nothing to distribute. It's just a positive 1. Well, multiplying by positive 1 doesn't do anything. Multiplying by -1 does. -1 times 3x is -3x. -1 times positive 12 is -12. The biggest mistake students make is not distributing negatives here. Be careful. So we've distributed 2 times 4x is 8x, 2 times -8 is -16. -1 times 3x is -3x. -1 times 12 is -12. Now we just put them all together and combine like terms. 8x minus 3x, that's going to be 5x. -16 and -12, that'll make -28. And that's our answer there. Okay? Nothing crazy at all. So that's how you add and subtract these guys. You simply distribute if possible and then combine like terms if possible. It doesn't matter if they're binomials, trinomials, or monomials, or anything else. Now, what about multiplying? Well, here's the good news. You already know how to do it. We've already done it. We just didn't call it that. Let's say I told you to take 6x squared y. Let's jump this up a bit. 6x squared y times -4xy to the third. That should look familiar to you. That's product rule. 6 times -4, that's -24. 2 x's and 1 x, that's 3 x's. 1 y and 3 y's, that's 4 y's. We did this on test 2. You just took a test on this, right? Remember, this is product rule. So when you're adding and subtracting these guys, you're just combining like terms. Distribute if you need to, but you're just combining like terms. When you're multiplying, you're just doing the product rule, which tells you to add the powers. So be a little bit careful. When you're adding and subtracting, the powers don't change. 8x and 3x made 5x. When you're multiplying 6x squared y times 4xy to the third, the powers combined, right? When you're multiplying, you use the product rule, these powers combine. When you're adding and subtracting, you're just combining like terms. Just be a little bit careful. Now, what we didn't say before was that you're doing a monomial times a monomial, aren't you? Does it really matter though? This is a monomial times a monomial, and that is what you were doing. We just didn't call it that because you don't need to call it that to do it. What if I did a monomial times a binomial? Well, gonna have to distribute. So we got 5x times 2x and 5x times -7. Be a little bit careful here. 5x times 2x is 10x squared, right? Because we are multiplying, we use the product rule, which tells us the power should add. 5x times 2x is 10x squared. And 5x times -7 is -35x. So that was the distribution. Now you come back and say, can I combine like terms? And no, 10x squared minus 35x does not combine. They're not like terms. You're done. So in both cases, it's fairly straightforward. Multiplying is not a big deal. You already know how to do it. It's just product rule. The thing, and you just at the end, you have to check and see, do I have any like terms? What if I said 3ab to the third, another monomial, times another binomial? It just doesn't matter, right? So this is number 1 here, this is number 2 here, this is number 3 here, trying to keep it a little organized for you guys. Distribute, even though it's ugly, 3 times 2 is 6, 1a and another a, that's a squared, 3 b's and no b's, that's b to the third. Pause it, slow it down if you need to, that's just product rule there. Now distribute here, 3 times -4, that's -12, 1a and no a's, so that's just 1a, 3 b's and 1b, and that's just 4 b's, so that's the distribution. And then we look down, can we combine like terms? Well, they both have a's, they both have b's, but the powers are not the same. And remember, the powers have to be the same, so you're done. So in a lot of cases, you just distribute in the power and nothing goes together and you're finished. Sometimes that's not the case. Let's go ahead and work a few more here. But this is the idea. I mean, you've kind of seen the instruction here, so let's just work a few more examples. It's kind of more complicated stuff. What if I took another monomial and multiplied it by a trinomial? Again, just the names just don't matter. You could do monomial, binomial, trinomial. I mean, it gets more complicated, right? There's more pieces, but in the end, it's all the same. So first step is to distribute, if possible. Second step, to combine like terms. Really, the steps are the same no matter what the problem. Whether you're adding, subtracting, or multiplying, you distribute and then combine like terms. So first, we'll go to the first piece. -4 x to the fourth, y to the fifth times 7x squared. -4 times 7, that's -28. X to the fourth and x squared, we are multiplying, so the powers add, that's x to the sixth. Y to the fifth, and there's no other y's there, so that'll just be y to the fifth. Now we distribute to the next piece. -4 times 4 is -16. Watch your signs. 4 x's and 1 x, that's going to be 5 x's because we're multiplying, add the powers. 5 y's and no y's, that's just 5 y's. Now go to the last piece. -4 times -10 is +40. Watch your signs. 4 x's and no x's, that's 4 x's. 5 y's and no y's, so that's 5 y's. That was the distribution. Now go through and combine like terms. They all have x and y, but the powers are not the same. This is x to the sixth, that's x to the fifth, that's x to the fourth. So once again, you're done. As complicated as that looked, you're done. Monomial times trinomial, it just doesn't matter. In fact, where this gets confusing is actually with the binomials, and it's not really any more confusing. It's just slightly different. Let's see here, that was number 1. Here's number 2. What if we said 2x minus 5, a binomial, times another binomial? This is where we will say a little bit more about it. Although it really is distribute and combine like terms, the question is, how do you distribute something like this? This is where that thing FOIL comes in. People love this, right? First, outer, inner, last. This is just an order to multiply in. It's saying take the first 2 and multiply them. Take the outer 2 and multiply them. Take the inner 2 and multiply them. Take the last 2 and multiply them. Couple of things here. First off, does the order that you multiply in matter? No. Second of all, do you need to, did you FOIL up here? What did you do up here? What was the cute little thing you remembered here? You didn't. You just distributed. I don't like FOIL, and it's not that it's wrong. It's just an extra trick to remember. It's like saying, well, when I drive to Santa Fe, I have to remember a certain way to go or I can't get there. Well, you don't do that anywhere else you drive, so don't do it to Santa Fe. You don't FOIL every other time you distribute, so don't start doing it now. It's not wrong. If you already know it and use it, it's fine. It's just, look, man, your brain is a limited thing. It doesn't have infinite space. Just try not to memorize things you don't need to memorize. Watch how I do this. I mean, it is going to be FOIL, but you don't need to think about that. Take the first piece, the 2x, and distribute it to both of the others. It's not 2x and 5, right? They're minus. Take the 2x and multiply it to both of the others. 2x times 3x, that's 6x squared. Be careful, because we're multiplying, the powers change. 2x times 9, that's 18x. There's your first two. And if technically that was your first and your outer, right? First and then outer. Now we'll do the next two. Take the -5 and go to both. So basically you take the first piece, go to both. Take the next piece, go to both. You don't need to FOIL. I mean, it is the same thing. I don't know. Just less stuff to memorize. -5 times 3x, that's -15x. -5 times 9, that's -45. Now we've distributed. Now we need to combine like terms. And in this case, there are like terms. We have 18x and 15x, which will go together. So we've got 6x squared. 18x minus 15x, that's positive 3x. And then the -45, the -45 is still there. So there's an example where you have to distribute and combine like terms. Again, if you want to call that FOILing, it's fine. I just like to think about it as the first piece times the back two and the second piece times the back two, and that's it. Let's do another one of those. Those are ones that give people trouble. Let's say, well, whatever, it doesn't really matter, does it? X minus 9 times 7 plus x, something like that. Another binomial times a binomial. If you want to FOIL, you can, but I would just say take the first piece and go to the other two. X times 7, that's 7x. X times x, that's positive x squared. Be careful. Now you've done that. Now take the 9 and go to both. -9, excuse me, times 7, that's -63. -9 times x, that's -9x. Again, if I'm going too fast, just pause it. So you've distributed. We took x times 7, x times x, first one times the back two. Now we take the -9 times the back two, -7 times, -9 times 7, -63, -9 times x, -9x. We distributed. Now let's combine like terms. And let's put this in the right order, highest power first. So the x squared goes first, that's done. I like to cross them off so I don't forget something. Here we have 7x minus 9x, so that would be -2x. And then the -63 just gonna sit there, and that's your answer. So FOILing, whatever you wanna call it, not a big deal, okay? I wanna do one more problem. I'm tempted to kind of squeeze it in here, but I don't wanna do that. We don't really have enough room, so we'll waste a whole nother sheet of paper, that's fine. The thing that throws some people off here, and this is not anything new, this is the same thing I've been saying the whole day, is this. Let's say I gave you this one. 3x minus 4 squared. What a lot of people like to tell me is that it's 9x squared plus 16. This is incorrect. It's worth noting sometimes what you're not allowed to do. If you have a plus b and it's squared, it will never be the first one squared plus the second one squared. And it doesn't matter if it's minus, it's still not going to be that. If you have two things added or subtracted and you square them, it is never the first thing squared and then the second thing squared. Because think about it. What's 3x minus 4 squared mean? What does squared mean? It means times itself. So what you have here is 3x minus 4 times 3x minus 4. That's not going to come out to this. It's going to come out to more than that, right? Let's work this out. Take the first one, go to both. 3x times 3x, that's 9x squared. We did see that, we didn't think that was going to happen. 3x times -4, that's -12x. Now take the -4 and go to both. -4 times 3x, that's -12x. -4 times -4, that's positive 16. So the 9x squared and the positive 16 did appear, but you missed this whole middle piece. And watch out, because that does not go to 0. 9x squared, -12 and -12, that's -24x plus 16. That's your answer. If you just tell me it's 9x squared plus 16, you missed the entire middle, and that's no partial credit, my friends. So be very careful about this. If you got two things in the parentheses, do not square the first one and square the second one. Sometimes people say, isn't that how power rule works? No. Power rule, which was from an old homework, says if they're all multiplied, then you can do each one to the power, right? 3 to the third, that's 27. X squared to the third, that's x to the 6. Y to the 4th to the third, that's y to the 12th. Here, I did each one to the power because they were all multiplied. That's not what's happening here. This is not 3x4 squared. This is 3x minus 4 squared. If there's a plus or minus in the middle, you need to do it out. Write it out twice, FOIL it, whatever you call it, and work it out, okay? Hopefully that's it, guys. That's the homework. A lot of this should be reviewed to you. If it's not, no big deal. Just get caught up, and I will see you on the next one.